So coming to the primary key, I just have one. So we can see this. So we have like one table called employee. Okay, and employee name. So if you see the employee name, Mary, Bob, Charlie, Mary. So we have two people with the same name, Mary, right? So if we don't have this employee ID column, then when I say like I want the details of the Mary working for department ID 1, like working for HR department, then there is a confusion like which Mary, right? So if I don't have the employee ID. Now, if I have the employee ID, then it's straightforward. I can say I need the details of employee Mary with the employee ID 1, right? So employee ID is the primary key here. So it's employee ID. It's used to uniquely identify the employees, right? So primary key is nothing but it's used to uniquely identify the records in the table. Okay, so primary key is nothing but it's a column or a combination of column in a table that uniquely identifies each row in the table. Okay, by default, when you say a column is a primary key, these three things will be by default applied. So uniqueness, so there will be no duplicate records, and indexing, automatic index creation for faster lookup, and data integrity. So no null values are allowed in primary key columns. So regarding indexing, I just want to give a heads up. So indexing, like I can give, like, let's take the example of a library. So in the library, we have like thousands of books, and without any order, finding one book will take forever. But if the library has an index, like an alphabetical list or a catalog, you can go quickly find the book's exact shelf and spot, right? Or you take any book, you will see the index in the initial pages with the chapter number, name, and page number. So it will help you to go to the chapter you wish to read directly with the help of that page number in the index. You need not scan each page. Okay, the same concept is used here. When you define a primary key, it will create an index on that column. Okay, and that will help the database find and retrieve the data faster without scanning the whole table. So when you query the database, saying you want the details of an employee ID with maybe 100, then PostgreSQL will quickly jump to where the ID 100 is. It will not scan each row starting from first record. It will not scan each row in the table. It will directly go to the index 100. Okay. So next is foreign key. So again, if you see here, there is one more table called department ID. And here department ID is the primary key and there is a department name. Okay. And how these two tables are connected, how employee and department tables are connected because of the department ID. Okay. So department ID is the primary key of department. And when you are using it in a different table, it becomes a foreign key here. Okay, so it's a foreign key now here. In the employee table, department ID becomes the foreign key. Okay, so foreign key is nothing but it's a column or a combination of column that creates a relationship between two tables. And it refers to the primary key in another table. And it enforces referential integrity, meaning you cannot enter a value in the foreign key column if that value doesn't exist in the referenced primary key column. So if I don't have 4 here in the department table, in the department ID column, I have only 1, 2, and 3. So in the employee table, in the department ID column, I cannot give like something like 4. Okay, that will throw error. So I cannot insert 4 here. These values should be one of these values. Okay. Yeah, and why do we need these two tables? Why do we need this separation? Any idea? So we can have everything in the employee table, right? I can just create a column here. I can give department name here, and I can give HR IT department. Why do I need the separate table?
Because of normalizing
the database.
Yeah. So if anybody have no idea, then I'll just give a simple example. So if I, like, for example, if HR, the department name HR changes to human resource or HRD, I want to update the name. Now, if everything was in a single table, then here it was like HR, here also it's HR, here also it's HR. So I have to update every record. I have to come to the employee table and update every record. Okay. So that is like tedious. So if we have separation, then it's like I just need to update. I can just update any name here and it will be like by default applied here. So I'm just giving the department ID here and I need to update at only one place. Okay. So primary key is a unique identifier, foreign key is a table relationship enforcer. So we have check, default, unique, and not null constraints. So check constraint ensures that values in the column or a group of column meet a specific condition. So suppose I have a age column in the table. So suppose I have a age column in the table, then I want the age to be greater than 0 because age -1 -2 is not valid. So when specifying the column name, I'll just put a check constraint, age should be greater than 0. So if I insert, while inserting the values, if I'm inserting less than 0, it will throw an error. So unique constraint ensures that values stored in a column or group of columns are unique across the whole table, like email address or username. So in a table, in each record, email address should be different. So I should give email unique. So if I insert a duplicate email, it will throw me an error. And to control whether a column can accept null, then you can use not null constraint. So email unique, not null. So it should not be null. You have to it should have any value. You have to pass a value while inserting. And to define a default value for a column, you can use default constraint. So enrollment status, Boolean, default is true. So if I'm not giving any value for the enrollment status while inserting, it will take true. It will take the value as true. So I'll just create a table here. Okay, so you can see like create table students, student ID, serial primary key, full name is varchar, it should not be null, it cannot be null. Email is unique, email should be unique and not null. So age, int is the data type and I'm applying check constraint here. Okay, age is greater than or equal to 5 and age should be less than or equal to 100. So 5 in between 5 and 100. So if I'm inserting any values other than this while insert into column, insert into table query, then it will throw me an error. And one more is check. So grade is a character and it is taking only one character. See, so it's like A, B, C, D. So grade, and I'm checking if the grade should be in A, B, C, D, F. So if I pass value E or Z or anything like any other than these characters, then it will throw me an error. And enrollment status, it's Boolean. So you have to give true or false. And if you don't give any value, it will take by default true because I am mentioning the default constraint. Okay, so I'll not insert and show because we have time constraint. So I'll not like insert and show, like insert into the table, I'll not show now. And I also wanted to tell about the composite primary key and foreign key. So table, like if you have two columns together, if you want to mention them as a primary key. So here you can see enrollment, student ID integer, course ID integer, enrollment, and primary key. I am mentioning two columns here, student ID and course ID. Okay, this means it's a composite primary key. So here the combination of these two column values should not be same. So I can have 1, 1, 1, 2. Okay, so student ID can be duplicated, course ID can be duplicated, but both these combination should not be duplicated. Okay, so the combination should always be unique and not null. So this is composite primary key, and similarly, it's like you have composite foreign key as well.
Sorry for interruption. I have a question regarding composite primary key. So how this data will be inserted? Like, can you just show us an example?
So inserting is same. So it's just like you should not pass same values. For student ID and course ID, the combination should not be same. So you want me to insert and show?
Yeah. Can you do that? Sorry for that.
Yeah. Let me just copy paste one of the. So insert into student ID. I'll give 1. Okay. Integer, and yeah, I'll supply a date value. Give me a moment. Okay, so the enrollment date, I can give something like, it should be year, month, and date. So yeah, let me try this.
Chetra, sorry to interrupt, but we didn't created the table first.
I didn't run this query.
Don't
Okay,
By
let me
giving the foreign
run this.
key,
Yeah.
are we creating a relationship between two tables?
Yes, but I haven't created a foreign key here, but in the next table, yes.
Close the round bracket after primary key.
So primary key.
Round bracket, because we're taking only half the creatable statement. No? One round
Okay,
bracket needs
okay, yeah, yeah. Okay, so I can give like multiple values also here actually. So it's like 1, 2. Okay, so 1 will be repeated here, and I can give like 1, 3. So the combination should not be repeated. Syntax error 1, 3.
No, values. You have
Value. Just remove the values.
Yeah. Yeah, so the combination should be unique. Yeah, I think we have only 3 more minutes left. So I can run the select. Yeah, so this is how it will be like 1 2 1 3. If I give 1 1, right, it will throw an error. Got it?
Yes, thank you.
Yeah. So yeah, it's like we have 2 more minutes left. So I think I have to continue like tomorrow. I wanted to like finish foreign key and the ER diagrams as well, but yeah, looks like I don't have time. So I can take the questions or I'll share the assignments.
Hey, hi, Chaitra. This is Mathura here.
We're discussing about primary key and foreign key. So primary key we already discussed. So I'll just revise once and I'll show like how to define foreign keys while creating the table. So we had employee and department table, and in the department we have department ID as the primary key, and in employee ID is the primary key, and department ID we are using in the employee table, and that becomes the foreign key. So how to define this? So we will have two tables, right? Create table department. Department ID is a primary key and department name is a varchar. So it's a character. And one more table called employees with employee ID as a primary key, employee name, and department ID. So department ID is referencing to, so it's a foreign key, correct? So it's referencing to the department table. So we will define, so we have to first define like department ID and give the data type. And then like how to define a foreign key. So we'll add constraint, foreign key constraint in this format. So keyword foreign key, then the column name, whichever is the foreign key. So the department ID is the foreign key here. So it references department ID from the department table. So references department of department ID. So this is how we define primary key and foreign key. And we also spoke about composite primary key and foreign key. I'll quickly visualize that as well.
Is it mandatory to give the foreign key in front of that statement?
Yes, foreign key is a keyword.
1 minute, Chaitra. You guys have to wait for the Q&A. Okay, so don't interrupt in between. Continue, Chaitra.
Yeah, so the keywords are important. So, and we have enrollment and grades table. So in the enrollment, we have student ID and course ID. So here one student can register multiple courses, but he can register to one course only once. So student ID 1 can register to course ID 1 only once. So there should not be a duplicate one student under student ID and same course number. There should not be a duplicate. So that is the reason we are doing a composite primary key here. Combination of these two columns is the primary key. So if you see student ID column, values are repeated 1, 1, 1, but the combination should not get repeated. So that's called composite primary key. And in the grades table also, again, we have student ID, course ID, and grades. So again, here student ID and course ID, the values, combination of these values should not get repeated. So one student can register to multiple courses, but he can register to each course only once. So that is what this will infer. So combination should be unique. And again, this student key and course ID together will become the foreign key in the grades table. Okay, composite foreign key. And that will refer the composite primary key here. Okay. So if you see the values here, 1, 1, it's already there here. 1, 2 is there in the enrollment table. But if you see the last value, 3, 1, student ID 3, course number 1, it's not present here, right? So it's not there here. So that is an invalid value. When you try to insert these kind of values, which is not there in the primary key columns, then it will throw an error. So you can try this. Since we have time constraint, I don't want to like insert and show everything, but this is the visualization. So you can try creating the table and inserting. Okay, so foreign key values should be one of the values from the primary key columns. Okay. So here, if you see, we have created the table enrollment, student ID, course ID is integer, enrollment date is a date data type, and primary key is combination of two columns. So this is composite primary key. This is how you define composite primary key. And create table grades, again, student ID, course ID, grade is a character, and primary key, we have to like, it's a composite primary key again, and foreign key is also a composite foreign key if you see. So foreign key, and you have to mention references. So it references which primary key. So this is the foreign key, and it references which primary key. It references the primary key from the enrollment table, and it's a composite primary key. So this is what it implies. Okay, this is about the primary key and foreign key. Next, let's